Jai Hind students, I am Dr. Garima Varshney, Assistant Professor at the EC Department of AKG EC. Today we will be discussing about Z and Y parameters of two-port network, which is a part of Unit 4 of NAS subject. So let's have a look what is two-port network. First of all, it is given as two-port network, so it must consist two ports. Two ports means this is an electrical network with separate two ports. First port is dedicated for input, one port is dedicated for input, and the other, that means second port, is dedicated for output. So I can say like this is the input port. So input port is having voltage V1 and current I1, which is the input voltage and input current, and the output port, which is port 2, having the voltage V2, which is the output voltage, and current I2, which is the output current. So inside this linear network, there can be a combination of capacitor, resistance, any electrical element can be inside this linear network. So this whole network can be characterized by various parameters. Various parameters like Z parameters can be one of the parameter which can define this linear network. The second one is Y parameters. Z parameters are impedance parameters. Y parameters are admittance parameters. Further, other parameters are hybrid parameters. That means H parameters. Others are ABCD parameters. So there are various parameters which can characterize this linear network. In this lecture, we will be concentrating on Z and Y parameters only. Further, so what is Z parameter? Z parameter is the impedance parameter. Impedance parameters are also called as Z parameters. So we need to have a look what will be the standard equations for Z parameters. So in Z parameters, the V1 and V2 are the dependent variables. Dependent variables. And I1 and I2 are independent variables. That means the value of V1 and V2 is depending upon the value of I1 and I2. So V1 and V2 are dependent variables and I1 and I2 are independent variables. So these are the equations. V1 is equals to Z11 I1 plus Z12 I2. Z11 and Z12 are the impedance parameters. We will be discussing how we can calculate and what are their names, what we can call these Z11 and Z12. And V2 is equals to Z21 I1 plus Z22 I2. These equations can be represented in the matrix form. Matrix form is like this: V1 is equals to Z11 I1, Z12 I2, and V2 is equals to Z21 I1, Z22 I2. This whole matrix is also called as Z matrix or impedance matrix. So now, if I want to calculate the value of Z11, this value I want to calculate. So in this equation, if I put I2 is equals to 0, then what will be the value of Z11? V1 by I1 will be equals to Z11. But what is the condition? Condition is I2 must be 0. So I can write when I2 is equals to 0, Z11 is equals to V1 by I1, right? Similarly, if I want to calculate Z21, I need to again do I2 is equals to 0. So Z21's value will be V2 by I1. So V2 by I1, when I have put I2 is equals to 0, will be equals to Z21, right? That means if I2 is equals to 0, I2 is equals to 0 means I2 is equals to 0 means this port 2 must be open circuit. Open circuit means there will be no current at the port 2, right? So, I2 is equals to 0 means port 2 is open circuit, right? Now, I need to calculate Z12 and Z22. Let's have a look. Okay, now now I need to calculate Z12 and Z22. So, to calculate Z12, I need to put I1 is equals to 0, right? Then Z12 will be equals to V1 by I2. So, V1 by I2, condition is I1 must be equals to 0. So, I am keeping I1 is equals to 0. Similarly, for Z22, I1 need to be 0. This term will be 0. So, V2 by I2 will be Z22. So, Z22 is equals to V2 by I2 and condition is I1 must be equals to 0. So, what is this meaning? I1 is equals to 0. So, if I want to do I1 is equals to 0, I need to open this port 1. So, when the port 1 is open circuited, there will be no current inside this port. So, this means this port 1 is open circuit, right? So, for Z11 and Z21, port 2 must be open circuit, and for Z12 and Z22, port 1 must be open circuit. So, these are the names. I can say Z11 is called as open circuit input impedance. Why input impedance? Because Z11 is equals to V1 by I1 when I2 is equals to 0. So, both the variables are from input side. That's why I call it as input impedance. Z12 is the open circuit transfer impedance from port 1 to port 2. So, Z12 is V1 by I2 when I1 is equals to 0. That means I1 is equals to 0 means port 1 is open circuit. So, that's why the name is open circuit. And transfer impedance, why it is called as transfer impedance? Because the one variable is from port 1 and this other variable is from port 2. So, this is transfer impedance from port 1 to port 2. Similarly, Z21 is also the transfer impedance and the value is V2 by I1 when I2 is equals to 0. So, open circuit transfer impedance from port 2 to port 1 and Z22 is V2 by I2 when I1 is equals to 0. So, I1 is equals to 0 means open circuit port 1 and output impedance because both the variables are from the output port, right. So, now how we can calculate these Z parameters of a T network. T network, so let's make a T network here. This is the T network. Let's say this is input port V1 and this is current I1. This is ZA, this is ZC, let's say this is ZB, this is port 2 V2 and this is current I2. So, I need to calculate Z parameter of this T network. So, here I can see two mesh are there. Let's apply KVL in these two mesh. Say this is current I1 and say this is current I2. So, apply KVL in mesh 1, KVL in mesh 1. First term will be V1 minus ZA I1 minus, in this impedance ZC, and the current flowing is I1 plus I2 is equals to 0. This is KVL in mesh 1. So, rearrange this equation, we will get V1 is equals to ZA plus ZC I1 plus ZC I2. So, this is my equation 1. Now, apply KVL in mesh 2. KVL in mesh 2. So, let's start from here, moving in the direction of loop. This will be plus V2 minus ZB I2 minus ZC I1 plus I2 is equals to 0. So, rearrange this equation, we will be getting V2 is equals to ZB plus ZC, wait a minute, V2 is equals to ZC I1 plus ZB plus ZC I2. This is the equation 2. So, now if I compare these two equations from the standard Z parameter equation, which was written in the slide 1, V1 is equals to Z11 I1 plus Z12 I2, V2 is equals to Z21 I1 plus Z22 I2, I can compare these two equations. So, from the comparison of the standard equations, I can say Z11 is equals to ZA plus ZC, Z12 is equals to ZC, Z21 is equals to ZC, and Z22 is equals to ZB plus ZC. For a T network, these are the Z parameters. So, fine. Now, let us have a numerical on this. This is a numerical. In this numerical, I need to calculate Z parameters of this network. Fine, this is port 1 plus minus V1, this is current I1, this is port 2 plus minus V2, and this is current I2. So, if I compare this circuit from this T network, I can say ZA is equals to 8 ohms, ZC is equals to 6 ohm, and ZB is equals to 0 ohms, because there is a short circuit where the ZB must be placed. So, I can say ZB is 0. So, from the previous analysis, using the same analysis, KVL in mesh loop 1 and loop 2, I can calculate these parameters. Z11 is equals to ZA plus ZC, which will be 8 plus 6 is equals to 14 ohms. Z12 and Z21 both will be ZC equals to ZC, those will be 6 ohms, and Z22 will be equals to ZB plus ZC. So, 0 plus 6 is equals to 6 ohms. So, these are the final answers: 14 ohm, 6, 6 and 6. Fine. Now, let us come to the Y parameters, that means admittance parameters. So, these are the admittance parameters. In the admittance parameters or Y parameters, I1 and I2 are the dependent variable. And V1 and V2 are the independent variables. That means the values of I1 and I2 are depending upon the values of V1 and V2. Fine. So, these are 4 Y parameters which are admittance parameters, and in the matrix form I can write in this form: I1 is equals to Y11 V1 plus Y12 V2, and I2 is equals to Y21 V1 plus Y22 V2, and this Y matrix can be written as this Y matrix, admittance matrix. So, how we can calculate the values of these 4 Y parameters? So, the value of Y11, is equals to, so to calculate this value of Y11, I need to put V2 is equals to 0 in this equation. So, when V2 is, then if V2 is equals to 0, I can calculate Y11 as I1 by V1, and the condition is V2 must be equals to 0, right? Similarly, if I want to calculate Y21, again I need to put V2 is equals to 0 in this equation, and the value of Y21 will be equals to I2 by V1, and the condition is V2 must be equals to 0, right? So, what do you mean by V2 is equals to 0? That means the port 2, let's come to the first slide. This port 2, if I want to do V2 is equals to 0, this port 2 must be short circuited. So, this means that port 2 is short circuit, right? Now, further, if I want to calculate Y12 and Y22, I need to do V1 is equals to 0, right? So, the value of Y12 is equals to I1 by V2, and the condition is V1 must be equals to 0, V1 is equals to 0. Similarly, Y22 is equals to I2 by V2 with a condition V1 is equals to 0. So, V1 is equals to 0 means port 1 is short circuit, right? So, Y parameters will be calculated by short circuiting a particular port, and Z parameters will be calculated by open circuiting particular port. So, sometimes these admittance parameters or Y parameters are also called as short circuit parameters, and the Z parameters or impedance parameters are also called as open circuit parameters. Fine. So, these are Y11 is equals to short circuit input impedance. Why input impedance? Because I1 by V1 is the value of V11 while V2 is equals to 0. So, this is short circuit input impedance. Similarly, these two are the transfer admittance. Because the two variables are from input and output ports. And this is the output admittance because both the variables are belongs to output port. The unit of Y parameters is ohm inverse, right? This is the unit of Y parameters, and the unit of Z parameters will be ohms because Z parameters are impedance parameters and these are the admittance parameters. Further, now we need to calculate Y parameter of a pi network. So, this is a pi network, input port, and this is port 2, output port. Let us say these are the admittances YA, YC and YB. These are the admittances, inverse of impedance. So, now let us apply KCL at two nodes. These are two nodes. Apply KCL at node 1 and at node 2. So, apply KCL at node 1. The voltage of node 1 is V1. So, current is coming as I1. One branch current is I1. Here 3 branches are there. So, I1 is the incoming current is equals to two, let's say, two outgoing currents are there. So, I1 is equals to YA V1 plus YC V1 minus V2, right? So, rearrange this equation. I1 is equals to YA plus YC times V1 minus YC times V2. This is equation number 1. Now, apply KCL at node 2. KCL at node 2. So, incoming current is I2. Let's say these two are outgoing currents. So, I2 is equals to V2 YB plus V2 minus V1 YC. So, YC times V2 minus V1. Rearrange this equation, you will get I2 is equals to minus YC V1 plus YB plus YC times V2. This is equation number 2. Let's compare these two equations from the standard Y equations, standard Y parameter equations. I1 is equals to Y11 V1 plus Y12 V2 and I2 is equals to Y21 V1 plus Y22 V2. So, if I am comparing these two equations with the standard equations, we can say that the value of Y11 is equals to YA plus YC, Y12 is equals to minus YC, Y21 is equals to minus YC and Y22 is equals to YB plus YC. So, these are the Y parameters of a pi network, right? Pi network. So, let us calculate the Y parameters of this network. So, this is V1, this is current I1, this is voltage V2 and this is current I2. This is a pi network. So, using the previous analysis, the KCL at two nodes, I can calculate these values. So, let us write what is the value of YA, YB and YC. So, YA is equals to inverse of this impedance. So, 1 by 4 ohm inverse. YB is equals to inverse of this impedance 1 by 8 ohm inverse and YC is equals to 1 by 2 ohm inverse, right? Now, calculate the parameters Y11, Y12, Y21 and Y22. Y11 is equals to YA plus YC. So, YA plus YC is equals to 1 by 4 plus 1 by 2 is equals to 3 by 4 ohm inverse, right? Y12 and Y21 is equals to minus of YC. So, these value will be minus of 1 by 2 ohm inverse is equals to minus of 1 by 2 ohm inverse. And Y22 will be equals to YB plus YC is equals to 1 by 8 plus 1 by 2 is equals to 5 by 8 ohm inverse, right? So, these are the answers. Using KCL, we can solve this. We will come with another lecture in next time.